Okay, hello everyone. Welcome back to the physically based animation class. This time for the 9th week. Today we will talk about or learn about physically based animation, but in 3D world. Still using Unity. Okay, so in the previous classes, you have already created your physically based animation or simulations in Unity 2D, two-dimensional games. Now we will try to create a simulation in 3D world. Okay, so for today's topic, we will talk about Rigidbody, the 3D version of it, and all the 3D implementations of KLP, KLPP, and force, freeform motion, friction, and momentum at the same time. So the implementations are not really different with 2D implementations. We will see later after we have learned about the Rigidbody 3D. Okay, so as you have learned beforehand, Unity provides a sophisticated physics engine that is ready and easy to use, either or both for 2D and 3D games. As with the other physics engine, this physics engine only approximates the physics models. So sometimes the result may not be as accurate as when we try to simulate it by ourselves. Physics engines for games aim for speed over accuracy. But it still produces a believable result. Okay, so this time we will delve into the 3D side of Unity. But we will not use the Havoc physics engine. Although it is available from Unity 2019. The Havoc physics engine is also supported only a preview package. For now we will learn or use the Unity physics engine itself, which is if I'm not mistaken, it is derived from NVIDIA physics. We have already talked about this when we learned about how to simulate the PBAs in Unity 2D using the Unity's physics engine. Okay, so let's start by creating a new project. I have my Unity Hub opened here. So I will create a new 3D project in Unity 2019. The only difference, for now and from now, we will use 3D instead of 2D template. So make sure the 3D is selected. And then I will move my location first here, not into my other classes, but into the PBA class. Okay, let's see here, and I will name it Hello Physics 3D. And then create as usual. And I think I will skip my video until my Unity is complete preparing my 3D game project, okay? Okay, now that my 3D game project is complete, let's continue. Okay, here we are told to rename sample scene into KLP. Let's do that. Okay, let's rename this sample scene to KLP. Just reload it. And then we will download some asset here. This is a HQ Racing car model, number 1203 by Azerillo. Azerillo. I'm sorry if I pronounced this name incorrect. Okay, let's do that. If your asset store is not opened, you can always go to the window menu and then click asset store. Okay, let's connect to the asset store. And then if you haven't please log in now. I have logged into my Unity ID here. Let's search for HQ Racing Car Model, HQ Racing Car Model. Let's just search it over here. Okay, this one, HQ Racing Car Model number 1203, or if you want, you can also use the 1202. Both by Azerillo here. Just select it and then download it. Yeah, it's only 4 megabytes, so I think it will be, yeah, it is downloaded very quickly. And then just click import. Yeah, and just select everything. Yeah, by default it already selects everything here, so just select import. Yeah, if by any case anything is not selected, you can just select or click all here. Okay, then click import. Yeah, and you will get Azarilo folder over here, which if you expand the folder, you will get HQ racing car, and you have materials mesh prefabs here. Yeah, let's continue. Okay, later on, yeah, this is how we use the Unity 3D physics engine by general. Yeah, we will select our game object, for example, car later on, and then we, on the inspector window, click the add component button and then search for rigid body. Yeah, because we have two rigid bodies. Yeah, one is rigid body itself with no any suffix. Yeah, and we have rigid body 2D. Yeah, please don't select the 2D version. Yeah, just select for rigid body only. Okay, let's try to, let's see, where is it? Yeah. Okay, never mind then. We will continue to simulate the KLP later by adding our car. But now let's talk about rigid body component first. Yeah. Okay, so if you see here, yeah, there's not much difference from 2D version. Yeah, we still have mass, drag, angular drag. The only difference is maybe the use gravity checkbox. Yeah, in the 2D version, if you recall, we have the gravity scale. Yeah, so let's see. But the properties mass is the rigid body mass in kilogram. Drag, the amount of linear drag, it will slow down the moving objects. Yeah, angular drag, as it says, the amount of angular drag. Use gravity, whether to use gravity or not. Yeah, by default, it uses the Earth's gravity, which is 0, negative 9.81, and 0 meter per second squared. Yeah, if you want, you can always modify this value on Edit Project Settings Physics. Let's see. Edit Project Settings. And then not the Physics 2D, yeah, because we are in the 3D world. So select Physics and you will have the gravity value of x equals to 0, y equal to negative 9.81, and z equals to 0. Okay, constraints, whether to limit rigid body movement and or rotation. And please be advised, yeah, because we have rigid body now, using rigid body will affect its transform, but not otherwise. Yeah, if you try to modify your transform, it usually does not modify the rigid body. Yeah, so we must choose to simulate using rigid body or transform. Yeah, if you want to use rigid body, but you want to manipulate it by yourself, yeah, you can turn on the is kinematic property of the rigid body. Yeah, for now, we will use the not is kinematic one. Yeah, it is turned off by default, so don't worry about it for now. Okay, let's try to simulate KLP in 3D world now. Yeah, let's open the car folder and find the prefab. Yeah, I have opened my HQ racing car number 1203. Now I have my prefabs here, and you may select anything, any color you want. Yeah, car 1203, black, blue, green, white, or yellow. Let me choose blue, and then just drag it over here. I will change the tool into a move tool here. Okay, and then we are told to rename the car into my car. Yeah, let's rename it. My car. The position is 000. And then we must reposition the main camera to 0, 20, negative 20, Let's do that. 0, 20, negative 20. Okay, let's see. The rotation X is 25. Okay, 25. Okay, my car is now here in the game panel. Okay, and then we may add a rigid body. Yeah, again, not a 2D one. Select the my car game object, then click add component, then just search for rigid body. Yeah, be careful again. Yeah, don't select the rigid body 2D. Yeah, now we use the rigid body only. And then uncheck use gravity. Okay, I will teach you how to move around in the scene panel. Yeah, it is not here in the slide, I think. Yeah, it is not here, but I will teach you nevertheless. Yeah, if you want to move around in the scene panel, yeah, optionally you may use the hand tool, or you may have any tool selected. Yeah, you can zoom in and zoom out by using the scroll mouse. Yeah, so I want to see my car model here in a greater detail, so I can zoom in, zoom out. Yeah, and then to rotate my view in the scene panel, yeah, hold the right mouse button, yeah, until you see the your mouse pointer changes into something like this. Yeah, an eye with some very small boxes. Yeah, in the lower right corner of your eye icon. Yeah, not your eye, obviously. Yeah, and then you can move around here by just dragging your mouse. Okay, something like this. And then if you wonder, yeah, the small 4 boxes in your lower right corner of your eye icon, yeah, actually resembles the movement icons. Yeah, if you are a gamer, you have already familiarized yourself with the WSAT movement. Yeah, here Unity uses the same movement pattern. Yeah, so you can use W to move forward, yeah, and then S to move backward, A to pan left, and D to pan right. Yeah, and as always, you can also combine the WSASD movement with the rotation of your scene panel camera. Yeah, additionally, you can also use Q to move downwards and E to move upward. Yeah, so remember, hold the right mouse button and then use WASD, Q, E optionally, and drag your mouse to look around. Yeah, this is how we navigate in the scene panel. Okay, the next step is creating a new script here. Make a scripts folder. Let's do that. Let's create a folder, scripts. Oh, sorry, scripts. Yeah, I will use S ruler here. And then let's create a new C# script, which is car KLB, I think. Yeah, hopefully I am correct. Oh no, car 3D. Okay, car 3D. Yeah, and then I will attach it to my car game object immediately. So I am sure my script is being used by my car game object. Okay, I will check it. Okay, I have my car 2D script attached. Then I can edit it. Yeah, of course, you can always edit the script before attaching it to any game object. Yeah, it's just a matter of preference. Okay, I will wait until my Visual Studio is ready. Yeah, I think it's ready now. Let's see. We will add a public factor tree field. Yeah, now we work in factor tree. Yeah, in 2D world, you work in factor 2, but now Usually we will work in factor tree. Yeah, let's add it. Oh, my Visual Studio is still preparing something, I think. Okay, I think it's ready. Let's add public. Not really ready. Public factor tree velocity, and then a private field. Okay, I will ignore this update for now. Oh, okay. And then a rigid body. Rigid body, again, don't select the rigid body 2D. Yeah? For the class name here, in 3D world, we use a rigid body only. Rigid body RP. And then at the start method, we will get the components as usual. RP equals to get component of rigid body. Yeah, and then to simulate the GLB, yeah, we simply set the velocity of the rigid body into the velocity field. Yeah, it's as simple as that. If you remember also in your 2D Unity, yeah, rp.velocity equals to velocity. That's all. Yeah, and since the update method is empty, I will just delete it. This, save it, go back to Unity. Yeah, and as always, you will see the velocity field. Now there is already exposed from our car 3D script to the Unity. Yeah, because we made the field public. Okay, if you see the inspector, and any public fields from our script is shown and can be edited manually and differently for every object. Yeah, you can modify the velocities field amount as desired. Yes, let's see here. Yeah, I have my car game object selected. Yeah, and with intentionally my move tool is selected also active. Yeah, and my setting here is global. Yeah, here you can remember the axis in 3D's world. Yeah, by remembering the color. Yeah, it's very simple. XYZ equals to RGB. Yeah, that means the x-axis positive is colored red, y positive is colored green, and z positive is colored blue. Yeah, XYZ RGB. Yeah, if you can't remember that, don't worry. Actually Unity prepare the cheat sheet here. Yeah, X is red, Y is green, and Z is blue. So if I want for my car to move forward, yeah, that means I must give the velocity in the same direction as my Z positive axis. Yeah, that's why here in the slide we are told to change the Z to a positive value to move it forward. Okay, let's do that. Yeah, let's say I will give the velocity is 1, and then let's see what happens. Okay, now my car moves forward, yeah, according to the velocity value of 0, 0, and 1. Yeah, if you want, you can modify these values on the fly. Yeah, don't worry, it won't be saved. Yeah, in our playtesting mode. So, for example, if I want my car to also move in the x direction, yeah, I can give it some value like 5. Oh, sorry, 5. And okay, it does not affect everything. Yeah, why? Because we assign the velocity field into our rigid body's velocity only once. There is in the start method. Yeah, so any changes you created here or you make here in the velocity field will not affect the velocity of your car. Yeah, you must stop your play mode, then try it again. Okay, if somehow I lose sight of my car game object here, yeah, you can simply double click it and Unity will bring the game object for you in the scene. Yeah, actually, Unity will pan or position the screen panel's camera. Yeah, so that the selected game object is right in the middle of our scene panel. Okay, let's see if I give my car's velocity is 5, 0, and 1, what happens? Yeah, it will move diagonally. Yeah, yeah, although we can't really tell if our car is moving to the z direction. Yeah, because the z's velocity is only 1. Yeah, so that's all about simulating KLB or uniform velocity in the Unity 3D world. Simple, right? Okay, as described before, yeah, any public fields on your script will be serialized and exposed on Unity Editor. Yeah, this allows us to modify the values for each game objects. Yeah, this is also the only way to modify any values of the any public fields, yeah, because we don't have any constructors. Yeah, to try it, let's duplicate this card. Duplicate. I will move it over here, and then I'll change the velocity into 5. Let's see what happens. Yeah, obviously the second car moves faster than the first car. Yeah, but here we can look here at the velocity value of my car. It's 001, but my car is 005. Yeah, so you can have a different value of the velocity field for each game object. Okay, I think that's all about the KLB simulation. Yeah, in the next video, we will try to simulate the KLBB in 3D world. Okay, let's continue to the next topic.